everyone. Welcome to Singapore Geospatial Week Plus 2020, an event organized by GeoWorks, Singapore's Land Authority Geospatial Industry Centre. We are pleased to bring to you 2 weeks full of geospatial webinars spanning various industry tracks and international speakers. Today, we are excited to introduce Daniel and Chris from GoodVision to share more about automating traffic data for transport planners and smart cities. If you have any questions during the webinar, please leave them in the Q&A box and we will answer them at the end of the webinar. Thank you, and without further ado, I will pass the presentation now to both Daniel and Christopher. Thank you.
Yeah, thank you, Stofan. And good evening, everyone, ladies and gentlemen. My name is Daniel Stofan, and I'm one of the founders and the CEO of GoodVision Ltd. My colleague Christopher Hargreaves is joining me today, and he'll show you the real traffic case studies which we did with partners in Singapore. Today we'll be speaking about the new trend in traffic data analytics. We're going to explain you how transport modelers can benefit from automation and artificial intelligence in their daily jobs when modeling traffic and designing the traffic infrastructure towards the smarter cities. Let me introduce our company a bit at first. GoodVision is a company from London, United Kingdom, and we work with transport planners daily. We have helped transportation specialists to achieve incredible efficiency and quality in traffic data analytics. This is our 100% focus. Our mission is to make the traffic flowing, making our streets safer, and increasing the quality of life of citizens, citizens' health, optimizing how the traffic is being driven through our cities. We aim to deliver better and easier working experience on traffic projects to modelers, planners, surveyors, and municipalities. In GoodVision, we cooperate with businesses on 5 continents already, including the top-tier traffic engineering organizations like PTV Group, Jacobs, WSP, and Ramboll, and also the transport authorities and municipalities like Florida Department of Transportation and the state of New York. Our solution is called the GoodVision Video Insights, and it is a one-stop shop for all the analytical tasks that the transportation industry requires. And it makes your daily work more enjoyable. Video Insights platform provides a comprehensive set of analytical tools, which save transport specialists up to 95% of their time by automating manual labor and replacing the conventional methods which we are used to. As a basic, we extract very accurate traffic data from video, and we allow to perform a wide spectrum of traffic analysis and modeling over it. The GoodVision Video Insights platform provides the advanced analytics, data visualization, and managerial reporting all in a single platform. And it's covering the whole process from operation from the traffic data collection to the decision making. Our typical use cases include the traffic volume counting, drone aerial analysis, traffic modeling, pedestrian and bike surveys, detection of various traffic violations and events, and the real-time traffic control. As GoodVision, we enable municipalities to be transformed into a data-driven smart cities of the future. And we're doing that by leveraging the existing city camera infrastructure and cameras as videos as one of the most important assets of the cities. And now let me tease traffic modelers a bit, and let me show you some of the end products from working with our tool. Just take a look at this model, the traffic model of the intersection. I opened this model in the PTV Visim software. This intersection has 4 arms. It has 16 traffic movements in total. And this model is fully calibrated with the real world data, with multimodal traffic volumes and vehicle speed. to the point that it represents the exact digital twin of the real intersection. And I have created this model in 5 minutes. And I'm sure you're now curious about how this is possible, because conventionally you would draw this model and calibrate it manually, of course. So, but let me first show you another example. The saturation flows. This is a key measurement of the on-street performance. It is the expression of the maximum capacity of the traffic movement on the intersection on highways. And such flows need to be calculated by conventionally by visually inspecting the real-world situation, which in most cases is video, in order to verify your traffic simulation when modeling it in BISIM or other simulation system. And this intersection on the image has actually 20 separate traffic lanes, and for each of them, saturation flow must be calculated and at least for 10 or 20 different readings per each lane. And this is an extremely time-consuming task and could take you a full 24 hours to do it. And I have calculated the sat flows on this example under 1 minute. So how did I do this so fast? Well, I used the automated traffic model generation feature functionality which GoodVision provides. And I'm going to show you exactly how I did it step by step. What I'll show you can actually save you extreme amounts of time and costs required on manual labor. And this model, or this method, which I'm going to show you, not only saves time, but also significantly helps to eliminate the human error when copy pasting the traffic parameters values from various Excel sheets to your models during the calibration, as you have done before. In the first place, what we are trying to achieve is to make your work more enjoyable. To perform the advanced traffic analysis in the way I teased you on my previous slides, you need the traffic data. And as you might see by now, the traffic volumes in spreadsheets or on a piece of paper is just not the way you want it. With GoodVision, you can extract, and you will extract, all the traffic from the traffic videos or cameras, and where every physical aspect of every visible traffic object is captured. The traffic attendants are classified into one of the 8 classes, and the whole trajectories with the behavior are saved into the database. This is the right format of the data, which allows you to perform any data analysis over and over. And I'm betting that your traffic data supplier will provide you with that as a part of the delivery after the traffic survey. The data which I was showing you on the previous slide is extracted within 1 hour time, and you're all set to perform the analysis interactively. The first common step is that you will describe the traffic movements or lanes which you want to analyze, and at the end include it in your traffic model. You can add names to the traffic movements or enter it lengths and distances. This platform allows you to define any custom origin destination traffic movement on any type of a junction, highway, or a roundabout. With that, you can also capture traffic events and use them as a data filters. For example, you might want to filter out just the cars that are stopping on a signal line. And this description of the scene, as you see in this example, is very quick and can be done even under 1 minute. The next step are the traffic parameters you can analyze. There is plenty of traffic parameters which you are obtaining during your analysis in GoodVision. There are basic traffic volume counts by each modality. You can identify the peak periods. You can measure the speed of every vehicle and identify the areas with reduced speed. You can analyze the time gaps between vehicles and the travel times in the flow. You can get the waiting time in queues and identify the delays. You can also calculate the sat flows, as I was mentioned before. And finally, you can export it all into a wide variety of traffic reports. One of the ultimate end products you can get with GoodVision, and we're finally getting to this step, is the automatically generated or created traffic model for PTV BISIM. As complicated as it might sound, creating the traffic model is as simple as clicking a button in GoodVision. Since everything on the traffic scene is set up already, you did it before. To create your model, you just simply go and click Create Visim Model, and the creation dialog as on the picture will appear. And here you can choose which traffic movements you want to include into the model, what vehicle classes will be included to model, and you can select also the options if you want to calibrate your model also by the vehicle, by traffic speed. And then simply choose what time period for calibration will be used, if it's a peak hour or a custom time range, and the time unit, which by default is 15 minutes. And after clicking to generate the traffic model, you will receive the impx Visim file in a minute, and you can open it straight away in your Visim simulation software. I've recorded this video to capture the whole process of the model creation I was talking about. The traffic model from GoodVision is already pre-calibrated, as mentioned. It is pre-calibrated by the traffic volumes and speed. The links will have the names according to your settings in GoodVision, and the network will appear on your Visim map background, as you have seen as you see on this example. And after opening it, you can run the simulation straight away and actually verify the model. For verification, you will need to calculate the saturation flows. You will need to do it to verify your model simulation if it reflects the reality on the intersection. And as mentioned before, in GoodVision, you can use that automated saturation flow calculation for all the traffic movements and lanes at once, simply by clicking Get Traffic Report and selecting the sat flows as the type of the report. Every country and traffic authority might have different guidelines for this, and GoodVision allows you to customize the algorithm of the calculation in the app. During this report creation, what do we do actually? GoodVision automatically identifies every single time interval with saturated free flow conditions and picks the top 10 or whatever the number is needed intervals with the most passenger car units per hour, and select this and report it in the table, as you can see below. This will take about 1 minute, and you will receive this the report for the whole intersection, lane by lane, movement by movement. This report is very transparent. It contains the tables as in the picture below, but also it contains a full list of identified free flow intervals and free flow readings that match your conditions. And now I would like to pass my word to Chris, who will explain you or show you this functionality on the real case study we've done on Queensway in Singapore.
Hello, everybody, and my name's Chris, as Dan mentioned, and I'm going to walk you through the features that Dan has mentioned, and I'm going to describe to you what we did with a local example in conjunction with our contact LKK consultants in Singapore. They went out and collected the data for us, and then we looked at the Queensway Singapore junction to see what type of analysis and data that we can extract and do within minutes. As we've mentioned, this is reducing your time and also very cost effective for you. And this is what every modeler is trying to or looking to achieve. We're looking to get the full simulation model with all the kind of parameters of the classification, the transferring of data from other Excel file sheets into PTV-Vism. So we want to do get a pre-calibration model done for you automatically, including all this information. So all you need to do in GoodVision is generate the impx file that contains all the locations and all the statistics that you need to create this model that you see here. And as you can see, we've got Queensway, which we extracted the data from GoodVision and uploaded it into PTV-Vism. And as Dan said, it probably took us about 5 minutes to kind of, you know, select what we wanted and then generate the report. So what we were looking at this intersection is that it's a 5-armed intersection. We were looking at 3 traffic movements. There's 9 lanes, and you can extract. We wanted to extract the saturation flow and also get some peak periods from this analysis. So as Dan has described and showed you, that in the describe scene in GoodVision, you will just be marking up the area, the described scene with your lines, and then this is calculating automatically all the information required to give you the visual details, which I'll show you. And also the AI is classifying all these objects for you and delivering the results within 1 hour once your footage is processed, which is very, very quick and very, very efficient. So let's look at how we've done this, or how we generate first the impx file. So we generate the impx file by simply selecting the movements within the system and selecting the classes we want, the interval, whether that's 15 minutes, whether that is 5 minutes, whatever interval that you're looking at. And then once you've selected this simple kind of click process and selection and adding your speeds, you generate the report and that will be sent to you in an email format in the file impx, and then you simply upload that into PTV-Vism, and it gives you a pre-calibrated model, which then allows you to make some minor kind of changes to the links to match up onto your PTV-Vism model, and also add the lanes. So you have to do some minor kind of extra kind of adding or manipulation to your PTV-Vism model, and all the results are fed in to the system and create your base model. And as we were stating, that this is going to save you 99% of your time with pre-calibration steps. So it's removing all these kind of manual pre-calibrations that you have to do, and actually get modelers modeling and using your PTV-Vism model more efficiently and effectively. Also, we're removing complicated calculations on Excel files, templates, removing the human error from this, so it gives consistent results. By using GoodVision, you have the data there, you generate and click, and you have your results all ready for you, which is going to save you a lot of time, and also it's very cost effective. So now let's look at the generation. So we've generated the impx file. It's uploaded into PTV-Vism, and also you'll have your flows from the PTV-Vism system. But you also can generate as checkpoints or pre-calibration checking from GoodVision. And you can generate the saturation flow, and it's possible for each lane automatically calculated based on real-time data from the GoodVision platform. So you can look at the calculations generated from PTV-Vism and also from GoodVision, and you can make sure that that calibration is exactly what you need for your model. And obviously, it's basically a quality check exercise that you're doing now, instead of looking at calculating and watching hours of video to create these saturation flows. It's a simple, quick check to see if the numbers are matching. And then this is the next kind of how I did the saturation flow. So we have one of the scenes from the Queensway. And all I've done is I've highlighted the lane or the flow of traffic that I want to look at. I've placed my green line, so you can see over there where there's a red arrow. I've placed the green line, and that is actually placing the position of the flow that I'm going to measure. Once I've put that line across the lane that I'm looking to measure, all I do is generate the saturation report, which you've seen at the beginning, and that will send me an Excel file to my my email address or to a client or even to a fellow co-worker, it produces this report. And these are the stats that I got from Queensway, Singapore, with the free flow reading for each lane, also each flow or vehicle. And you've got your average, your min, your max times, you've got the classifications per vehicle. And as you can see here, I've highlighted some of the information that I've able to calculate, and that was in a minute or so from clicking the selection and getting the report to my inbox. So that pre-calibration is done for you. Also, as I mentioned, it gives you a visualization of data, and that's very important here, as you can see, with another area of checking the data that you have in PTV-Vism, but you also have your object distribution graph, so you can look at the object distribution of vehicles, and also, as I mentioned, peak periods. So the system automatically highlights the peak period within your footage to give you a breakdown here in the bottom left. It's showing you that the peak volume, and then also the period, so it's from 7:30 till 8:30, and it gives you a breakdown of this classification. So also that should kind of flow through into your PTV-Vism model. Also here we have the vehicle list report, which is at the bottom right, and that is actually showing you, again, a granular view of the vehicle, the gap time, the entry and exit, and the travel time and speeds also. So it's giving your average speed per that classification, and it's all visual aids helping you, making sure that you deliver real-time traffic data within hours from the upload and generation, and then creation of the data into your PTV-Vism model in minutes. And this will definitely save you valuable time, and it's very cost effective to help you with your models and projects within that you're looking at. So thank you very much for your attention. I'll pass it back over to Dan. If there's any questions, let us know.
Yeah, thank you for your attention, and we're ready for questions.
Hi, so I think we have a couple of questions. So the first question is, how long will it take for the AI to recognize new types of vehicles, and how much traffic footage is needed for the AI to learn this?
So that's two complicated questions, but actually it's very simple to answer them. The first thing is that there is no customization needed in order to learn the AI for your, let's say, geolocation, if you want to perform the survey. The other part of the question was, in order to learn new types of classes outside of the standard set which we already support, GoodVision support that as a custom, extension. We do that often and regularly. It's hard to say how much footage or how many samples, but if you're familiar with the artificial intelligence, there's quite a lot of a variety of imagery needed to do that. And the time period can range somewhere between 1 month to 2 months to deliver the model that can classify new types of vehicles, if this is possible technically. Yep.
Okay, and the second question is, how is the performance or detection rate influenced during night or any other disturbing light, for example, sunset, fog, or heavy rain?
Yeah, these were the common problems of let's say traditional computer vision techniques, because this area, of course, is very attractive since the emergence of the IP cameras. And these were the most common problems that our clients were tackling before. So night, shadows, obstacles, objects covering each other, fog, and heavy rain, of course. The level of artificial intelligence which is running under the lid of GoodVision platform is based on the detection or inference, which is classifying or recognizing vehicles by their appearance. And we're training. We have trained and are still training our system, of course, continuously on the large set of large data set which we are collecting from all around the world. And it contains, of course, imagery from almost every, you know, how to say, country globally, from every type of weather conditions during the night, during the day. So basically it works generally in a way that if the naked eye of the human can spot and recognize the object, then our system can do it as well.
Yeah. So in night vision or in the night, we can't pitch black, but if there is backlighting and you have the silhouette of objects, the system is trying to identify vehicles, their shapes and so on. It does reduce the accuracy because again, if you can't see it with the naked eye or you can't detect it yourself, then the system, it doesn't enhance, it's really looking at the physical shape of the vehicles. So in certain conditions, and if people have got some certain scenarios, we always review them and we let clients know if this is possible or it isn't possible to provide this service for them.
Yeah.
The next question is, can we monitor pedestrian movements? What about cyclists, PMDs, for example, scooters? Can they be differentiated?
Yes, we can monitor pedestrians and then bicycles. These are the standard classes which you are getting with any traffic survey which you are performing through GoodVision. The scooters, the motor scooters, are the part of our motorcycle category. So there is like no differentiation yet. But of course, we see the new movement or a new trend also to that there is a strong need to separate the e-scooters, for example. So this is like a development which is like ongoing in GoodVision, and in the future we want to provide also these new, I would say, modern classes, but which need to be considered for the new model schemes as well, as the bicycles are today.
Thank you. And another question is the video analytics able to motion capture traffic movement and process trajectory for grade separated junction or flyover or even elevated highways?
I don't know if I understood correctly. Could you please repeat the second part of the question?
Whether the video analytics is able to motion capture traffic movement or process trajectory for grade separated junctions or flyovers or even elevated highways.
Okay, so the actual video analytics is done on the micro level, so it's intersection by intersection. The connection between the intersection is done with other methods. GoodVision also provides some methods to make these, let's say, meso models or macro models. One of these methods is, for example, the automatic number plate recognition, which can, you know, very precisely connect the flows from one intersection to another. But like the degree identification just automatically, just by visual appearance, is not something which is, you know, supported. Today, this is a very, you know, complicated problem, and has to be degree identification has to be done with some like attributes, like for example the license plate, or with some manual approach.
But we can detect if you have a flyover or elevated highway, depending on where you place the lines or the zones within the described scene, you can identify the in and outflow of that vehicle and the numbers to understand the volume that is going through under, you know, an elevated highway. Trajectory is obviously broken because we don't see through things. So if you have a flyover and you have a vehicle entering, and if there's an opening, we can see the vehicles going under the vehicle, but not through. And again, you can measure easily the exit points of the categories or objects leaving the flyover. So we have done cases like this with islands, with flyovers and highways where we can detect the volume of cars going on and off any part.
Okay, and perhaps we have time for just one more question. So the next question is, what types of cameras are required to apply the detection? Can existing installations be reused?
Yeah, this is one of our main first drivers when we created such a platform. We wanted to leverage or utilize the existing infrastructure. So GoodVision is the camera manufacturer agnostic. You can use your existing cameras. You can use fixed cameras in the city, or temporary cameras which the surveyors are used to use for the traffic surveys. There are certain, of course, qualitative recommendations and requirements. But today, in the 21st century, there is plenty of, a big offer of cameras which are providing decent image quality and the video quality that can be, is eligible for GoodVision's processing. So basically, it is bring your own camera. Yeah, you can use your own cameras and existing ones, even the older ones.
But it's also on that we do have parameters around the cameras. So we say from 720p going upwards and 30 frames per second, or minimum 10 frames per second. Obviously, if it's not very good quality when you view it, the results can be different. So the better quality the camera, but the best thing, as Dan's mentioned, it is open to any brands. It's just the parameters. So you can use, as you said, existing CCTV cameras, anything like that that is on a network, you can utilize, and you haven't got that investment for hardware into your projects.
Okay. Thank you. Thank you so much, Daniel and Chris, for answering all the questions. So I think there are a few more questions that we have yet to answer. So perhaps, Daniel, you could leave your email address in the chat box. And if the attendees have any other things, they can reach out to you directly. So
Yes.
before we go, I'd like to thank everyone for attending the webinar today and for all the engaging questions. So before you go, please check out our other webinars that we have lined up for you by scanning the QR code and joining the conversation by using the hashtag #SGGeoWeek. So thank you, stay safe, and we hope to see everyone soon.